name is Amber.
My name's Mary.
My name's Nielle.
My name's Maddie.
So we're going to start with some safety. In the lab, you always need to have your gloves,
Your goggles.
Long sleeves and long pants.
and closed-toed shoes.
This is our notebook where the dilution concentrations were calculated, but first let's talk about the stock solution. A stock solution is a concentrated solution that can be diluted to a lower concentration. Our stock solution was transferred from the stock container into a new 150 milliliter beaker.
Did you really think I was going to drink that? Don't do that. Lab safety rule.
Now we're starting dilution 1, but first let's talk about the meniscus.
A meniscus is the curved surface of a liquid in a container, such as a pipette or a graduated cylinder. It forms due to surface tension and the adhesion between the liquid and the container walls due to intermolecular forces between the liquid molecules in the container. For water and other polar liquids, the molecules adhere to the container, creating a concave meniscus. Meniscus are read by reading the bottom of the meniscus at eye level.
A dilution is a less concentrated solution made by adding a solvent to the stock solution. The stock solution and dilutions are related through the dilution equation, which is C1 times V1 equals C2 times V2. C1 is the concentration of the stock solution. V1 is the volume of the stock solution used. C2 is the concentration of the diluted solution. V2 is the total volume of the diluted solution.
To derive volume 1 using the experiment, multiply C2 by V2, then divide by C1. Our volume 2 is 25 milliliters in a volumetric flask, and we chose concentration 2 to be 0.01 molar. So in the first dilution, V1 is calculated to be 12.5 milliliters of the 0.2 molar stock solution. Then water is added to the 25 milliliter volumetric flask mark. For the remaining 3 dilutions, we used the prior solution created for the dilution as follows. To calculate initial volume needed, we use the same C1 V1 equals C2 V2 equation. All of our members will now show the technique used for this process. Here's an example of a 25 milliliter volumetric flask with a meniscus filled exactly to the line. And don't be afraid to ask for help from your lab mates when reading the meniscus on the graduated pipette. For accuracy and precision for your last milliliters in the volumetric flask, use a plastic dropper pipette. And finally, here are our 5 solutions. On the far right is our original stock solution, with each dilution to the left decreasing in concentration.
And of course, don't forget to properly dispose of all liquid down the sink with plenty of water and to clean all glassware and materials thoroughly.
Bye.